Jai Hind. The topic for today's discussion is software matrix. This topic is being covered in Unit 3. So basically, the very first question is, what is software matrix and why we need them? So basically, it is how to measure the size of a software. When we say what is the size of the software, how you decide it? How much will it cost to develop a software? That is, when you go for the costing part, there must be some there must be some predefined formulas available with us, or universal formulas available with us. So on the basis of which we can decide what is the cost of my software. How many bugs can we expect? This has also become a very important part of my software matrix, because again I am evaluating my software. So software matrix, these are the criteria on the basis of which I am evaluating my software. When can we stop testing? That is, when we are going for the testing part, we should have some rules on the basis of which we are taking the decision. Now we are stopping the testing part. When can we release the software? So this is the reason why we go for why we need to study the software matrix. What is the complexity of a module? What is the module strength and coupling? What is the reliability at the time of release? Which test technique is more effective? Are we testing hard or are we testing smart? Do we have a strong program or a weak test suite? So these are the few questions which says, okay, go for the study of software matrix. That is, software matrix, they are required. So Pressman, according to Pressman, it says a measure provides a quantitative indication of the extent, amount, dimension, capacity or size of some attribute of the product or process. So measurement is the act of determining a measure. So the metric is a quantitative measure of the degree to which a system, component or process possesses a given attribute. According to Fenton, what he says, that defined measurement as it is a process by which number or symbols are assigned to attributes of entities in the real world in such a way as to describe them according to clearly defined rules. So we are having multiple definitions available with us for the measurement part. So how you define exactly what is software matrix? It can be defined as the continuous application of measurement-based techniques to the software development process and its product. That is, we are measuring certain attributes of my software to supply meaningful and timely management information, together with the use of those techniques to improve that processes and its product. So what are the areas of application of software matrix? The most established area of software matrix is cost and size estimation techniques. The prediction of quality levels for software, often in terms of reliability, is another area where software matrix have an important role to play. That is, when we are deciding how much reliable my product is. The use of software matrix to provide quantitative checks software design is also a well-established area. These are the few categories of my software matrix: product matrix, process matrix and project matrix. That is, we can categorize the software matrix into three parts: product, process and project. What is a product matrix says? It describes the characteristics of the product such as size, complexity, its design features, performance, efficiency, reliability. That is, when we are working on these criterias or characteristics, we say that we are evaluating the matrix of a product. What is a process matrix? It describes the effectiveness and quality of the processes that produce the software product. That is, to come to a final output, you need to do certain kind of activities you need to perform certain functions. Now, when we are evaluating those functions, we say we are working on the process matrix. So, what are the examples? Effort required in the process, time to produce the product, effectiveness of a defect removal during development, number of defects found during the testing, maturity of the process. So, these are the things which we study when we say we are studying the process matrix. What the project matrix describe? They describe the project characteristics, that is your overall product. It is a number of software developers, cost and schedule, productivity. So, these are the aspects on which we work when we say that we are evaluating or finding the project matrix. Now, Halstead's software science, in 1970, Professor Morris Halstead and his team at Purdue University developed the software science family of measures, that is the matrix which can be used for the software engineering. Halstead used a few primitive program parameters to develop the expressions for the overall program length, potential minimum value, actual volume. So, these are the different matrix on which we have designed or measurement has been done. Language level, effort and development time. So, a program is considered, what is a program? It is considered to be a series of tokens, and if we count the number of tokens, some interesting results may emerge. Now, the thing comes, what is a token and how the token count is being done. All software science measures are functions of the counts of these tokens. Tokens are classified as either the operators or operands. So, when you write a code, you are having operators, you are having operands. So, these are being considered as token in the Halstead software science concept. Generally, any symbol or keyword in a program that specifies an algorithmic action is considered an operator, and the symbol which is used to represent data is considered as operand. Punctuation marks are also categorized as operators. Variables, constants and even labels which you write in your code, they are acting as a operands. Operators, these are all the mathematical functions, they are being considered as operators. Now, your slash, asterisk and the command names such as while, for, printf, these are my functions. And some languages, they support the special symbols, parentheses, round brackets, function names, all has been considered under token count. Now, the thing comes, vocabulary of a program. When we say that we need to find the vocabulary of a program, then this is the formula. Eta is equals to eta 1 plus eta 2. Now, what is eta? It is the vocabulary of a program. Eta 1, that is the number of unique operators, and eta 2, it is the number of unique operands, because operators, they might be appearing at multiple places. We are working on the unique part. So, the size of the vocabulary of a program, which consists of the number of unique tokens used to build a program, is defined as vocabulary of a program. Another important matrix is the length of the program, which is equals to n1 plus n2. What it says? The length of the program in terms of the total number of tokens. So, the total occurrences of the operators, and n2, it is the total occurrence of my operands. Another important metric is volume. It is being calculated as n into log base 2 eta. And the unit of measurement in this case is bits. Always the output is coming in form of bits. What the volume says, it is the actual size of a program if a uniform binary encoding for the vocabulary is used. It is the actual size of a program if a uniform binary encoding for the vocabulary is being used. It is also interpreted as the number of mental comparisons needed to write a program of length N. This is another important definition of the volume of a software. Another important metric is my potential volume. So an algorithm may be implemented by many different but equivalent program. For example, if I'm saying I'm writing a sorting or the searching, the algorithm, it can be that same function, sorting or searching, it can be done in various ways. Similarly, a single algorithm, for example, if I'm finding the Fibonacci series, you can use have the output with the help of a recursive function or a non-recursive function. So I'm having different equivalent techniques for the same function. So a program that is minimal in size is said to have the potential volume, and it is being shown with the help of V asterisk. Any program with volume V is considered to implement at the program level L, which is defined by L, that is program level, and this is the formula for program level. If the value of L is 1, then it represents a program written at the highest possible level. Another important metric is difficulty and effort. The inverse of program level is difficulty, that is D is equals to 1 by L. As the volume of an implementation of a program increases, the program level decreases and difficulty increases. And what is effort? Effort E is equal to V divided by L, and since V, the relationship between D and the L is inversely proportional, so we can say that E is also equals to D into V. The unit of measurement of E is elementary mental discriminations. What is estimated program length? This is the formula for estimated length of a program, that is N, in this case eta 1 log base 2 eta 1 plus eta 2 log base 2 eta 2. The first hypothesis of software science is that the length of a well-structured program is a function only of the number of unique operators and operands, and that is why here the eta is being referenced. If the number of unique operator and operands are known before the completion of a program, possibly by using a program design language, that is PDL, and knowing the programming language chosen, because we could have different programming languages and they are having different constructs. So we need the both PDL as well as the program that is your language platform. Then it is possible to estimate the length of the program using above equation. For example, the counting rules for C. It is being given by Yogi in 1995. Comments, they are not being considered. That is, it is being discarded. Identifier and the function declarations, again, the identifiers and the declaration part, it is not being considered. All the variables and constants, they are being considered as operands. Global variables used in different modules of the same program are counted as multiple occurrence of the same variable. This is very important for the global variables. Local variables with the same name in different functions are counted as unique. For example, I am having two functions, add and subtract, and there I am using the local variables. Then for the add function, it is my unique operand, and for my subtract function, it is another unique operand. Function calls are considered as operators, that is, if you are writing add, this is being considered as my operator. All looping constructs and all your control constructs, that is, when I am saying looping, do, while, for, and when I am saying control, that is if else, switch, etc., they are being considered they come under the category of operators. In control constructs, switch case, as well as the case statements, they are considered as operators, which I had told you already. The reserve words like return, default, continue, break, size of, that is, if I talk about the C, I am having 32 reserved keywords, they are being considered as operators. All brackets, commas and terminators also, that is your semicolon, they are coming under operators. Go to, it is being counted as operand. Unary and binary mathematical operators, your logical operators, they are again being termed as operators, come under the category of operators. In the array, such as array name, index, array name and index, they are considered as operand, and your this symbol square bracket, it is being considered as operator. In the structure variable, as a structure name, member name, in all these things, they are being they are considered as operands, and here your arrow or the dot, they are considered as operators. Same names of member elements and different structure variables are counted as unique operands. All hash directives, they are ignored. So this is a simple code for my sort program. So here I need to identify unique operator and unique operands in the sort program, then we are going to calculate their occurrences. So this is the table. Here the operator, let's come to the int part, int sort, then what I am having? I am having the round bracket, then int x, I am having these square brackets, again int and n. So if I see, then my int, it comes under the category of operator. Name of the function is sort. It comes under operands. Then I am having these round brackets. Round brackets, they are acting as operator, comma, it comes under operator. Then these square bracket, they are again come under the operator. So when we are counting the unique, we need to first identify what are the tokens, that is separately operators as well as operands. So these are the things. Int, how many times int has come? 4 times. Let's calculate. 1, 2, 3, and here I am having 4. That is your data type. It is being, data type is being come under the operator. It has occurred 4 times. Then round bracket, it is very important to note, it is acting as a unique. That is, you don't need to identify these 2 symbols separately. Got it? Then we are having the comma, square bracket, here we are having if. This mathematical operator, then semicolon, for, equal to, I am having this mathematical operator, and all these things when we have calculated. Now these are the symbols which are coming under operator, these are the symbols which are coming under my operands. So here eta 1 comes out to be 14. Here eta 2, it comes out to be 10. Here we have calculated the number of times they are coming in my simple function. Here n1 is 53 and here n2 is 32. So I have got all the things which I needed for my further computation. So here what we are finding? Estimated program length. This is the formula. So I am putting the things here, and this is the value which I got after putting up eta 1 and eta 2 in my formula. Thus, even before constructing the software program, the estimated program length calculated as 87 tokens approximately. We need to go with the integer part. When we calculate the length of a sort program, what is the length? n1 and n2. Now I am getting 91. Vocabulary of the program, that is eta 1 and eta 2, it comes out to be 24. Volume of a program, after putting the things, n is 91, eta is 24, and after putting the values in my formula, I got this much bits. Answer is, if you remember, the output is coming in bits, we have converted it into bytes. So the estimated length of the program is 87 tokens approximately, which we have calculated here. Program actual length is 91 tokens. If you look here, actual length. And the estimated program length is within the 10% of the program actual length. So this is all about few software metrics which we have studied. The rest of the software metrics we will discuss later on. To prepare my slides. Thank you.